Hello everyone and welcome to this video tutorial. My name is Javier Ramirez Molar and I am currently studying the Multi-Cloud System Master at Tajamar. Today I am here to present a project I have been working on called TerraKubeSphere. In this video tutorial we are going to deploy our application and explain it in this design using tools such as Docker, Kubernetes or Terraform. This first thing we will do is to create a Docker image for our application and upload it to our Docker Hub repository. Consequently, we will use Terraform to deploy several resources in our Azure account. Among them, we will deploy an ACR along with the Docker image we create early to store it there and have it ready to deploy in our AKS. In addition, we will also deploy monitoring resources to later associate them to the resources we deploy, such as Grafana and Prometheus. Finally, once everything is deployed, we will use Kubernetes to deploy the image of our app in the AKS from our ACR, accessing it through a browser. So, in this first part, we will see how to create our image and put it inside a Docker container and how to upload it to our Docker Hub repository. So, I have my own web app and this is the app that we use to this example. We need to have Docker installed on our operating system. You can download it from this page, and also we need to have installed Nginx. You can follow this page to do it. So let's start. We are going to see how to build our first image. So the first step is to create a new directory. You can see that I already have created. And then we need to create a file named index. Indexing the file, we have our application. And then we need to create a file named docker file. So we need to open Dockerfile and copy and paste this. This Docker file defines a new Docker image that uses the official Nginx image as a base and then copy the index file to the appropriate location in the image. A Docker file is a text file with instructions to build a Docker image. Then we need to start and build our image Docker from Dockerfile. This command builds a new Docker image with this tag using the Docker file in the current directory. Now, to view the Docker image that I have created, we need to execute this command, Docker image, and we can see here, this one. This tells Docker to run the app container and map the port 80,080 on your local container. And if you open a web browser and navigate to localhost, you see the app displayed on the web browser. Now, we go to see how to upload our image to Docker Hub. You must first create an access token, log into Docker Hub and click your profile image. From the pop-up menu, select account settings. On the resulting page, click security in the left navigation and then click new access token. So we need to run this command where name is your Docker Hub username. You will use the access token you just generated. So finally, we are going to tag our new image and then push it into Docker Hub. First, tag the image with last using this command that the image is tagged. We can push it into Docker Hub with this command. When the push completes, you should find the app image in your Docker Hub repository. And that's all there is to building a Docker image. In this second part, we will examine the various Terraform files required to deploy all the resources needed for this scenario. The primary components include Azure Container Registry, where our Docker image will be stored. We will deploy both the Azure Container Registry and Azure Kubernetes service in the same Terraform file. We will deploy our image from the ACR. Additionally, we will set up monitoring resources such as Prometheus and Grafana. So I have these files that contain the main Terraform configuration, including resources definitions, variables, providers, outputs, and other settings. The provider configuration files specify which providers Terraform should use and configure settings specified to each provider. In this case, our provider is Azure. The next file is the main file. Here I say that I want to deploy a resources group, my AKS, where we deploy our app. my ACR, where we are storing and deploy the Docker image. ACR is a private registry that enables you to store and manage Docker image for your organization. This scenario utilizes the Terraform new resource to execute a series of ACLI commands to build the application image and push it into the Azure Container Registry. The following code snippet shows how we are using Terraform new resource to invoke a shell script that runs the ACR build command. New resource is a special resource type in Terraform that represents a resource with no physical manifestation, and the provisioner block defines how the resource is provisioned. It uses the local Excel provisioner, which allows executing commands on the local machine where Terraform is running. Deploying a containerized application in a Kubernetes cluster requires the proper permission to access the Docker image from the private registry. Azure Role-Based Access Control is the authorization system for managing access to Azure resource. In our case, we need to grant access to a managed entity in a particular scope. We do not want to provide full access to our container registry, which could compromise security. To limit accessibility, we will limit ourselves to the ACR pool scope only. And if we keep scrolling down, we have defined other resources like Kubernetes and Prometheus role. And we have our log analyst workspace and Azure monitor workspace. We also have the variable file that containing the variable declaration using the resources blocks and the output file that containing the output that needs to be generated on successful completion of apply operation. We are going to start Terraform with Terraform init. Then we are execute Terraform plan. Terraform creates an executing plan describing the infrastructure that will create, update, or destroy based on existing infrastructure and your configuration. We check that everything is okay, and finally we will deploy the resources. We let it load, and I show you the resources from the Azure portal when Terraform is finished. And Terraform implementation is finished. And if we go browsing through Azure portal, we can see the resources we have. And with this, we already have our image in a Docker container stored in our ACR. We can check in the following way, execute this command, and we can see here. As we can see here, all the resources have already been created for us. For example, we have our AKA setup here. To monitor our AKAs, we can use the following tools: Grafana for visualization, and with it, we need to have Azure managed Grafana workspace. We also have Prometheus for metrics collections. We need an Azure monitor workspace. And finally, we also have container insights for log collection. To activate all of these, we need to navigate to the Insight section on the left panel. As we can see, it will leave us the option to configure it and activate everything. This is what we maintained early. Each service stores the metrics in a workspace, and we need to click on configure to start to collecting information. And when it's done, the initial panels will show up where we can see that it's already collecting information from the nodes, for the node poll, for example. And as we can see, both Prometheus and Container Insight are already activated. If we come to Insights, we will be able to see more panels. All of them are customizable, and searches can be done through filters. We can see panels of our cluster, also of the reports for the nodes, for the controllers, and finally for the containers. As we can see, several rules have already been created in Prometheus. For example, this rule group for our AKAs with this Azure Monitor workspace. And if we click here, we can see that the AKAs is monitoring correctly. If we want to view the Grafana panels, we copy this link in our browser and we wait and register with our account. And this will be the main page of Grafana. We can already see the rules that are collecting from Prometheus, and we can configure as many as we want. We choose one of these and see all these panels. One of the great advantages of Grafana is that all these panels are highly customizable. In this third part and finally part, we will define a YAML file containing a deployment that specifies the image of our application of the Azure Container Registry. where it's stored. Additionally, we will include a service to expose the application. So we have this manifest file. In this manifest files, we can see defined our deployment where we indicate the container where it has stored our app image and the service to expose the app. So we need to update the manifest files in Azure like this. And then we need to connect to the cluster. Verify the connection to your cluster by running the following command. Make sure that the node's status is ready. It's alright, and then we need to deploy the app. Deploy the application by running the following command. And when the application runs, a Kubernetes service exposes the application interface to the internet. The process may take a few minutes to complete. To monitor the progress, run the following command. Initially, the external IP of your service is shown as a pending. When the external IP address changes from pending to a real public IP address, we go to our browse and we will see how our application is displayed. And we will be done. So up to this point in the tutorial video, I hope you have been useful and interesting. If you have any question or want to propose ideas, do not hesitate to contact me and see you in the next one. Thank you very much for watching.